So most of the time humanity had been on the planet, we witnessed a very slow warming from 5 to 12 degrees over a 50,000 year period, followed by a warm or cold period, 10,000 years, and then 50,000 years of slow declining temperature. It was something that we could adapt to. Then something happened. The last ice age maxima was between about 24,000 BC and 19,000 BC. I think there's only two potential causes that have these effects. Either a meteor impact or a megavolcano eruption. There can be little doubt that North America was devastated by a meteor impact around 10,765 BC. 75% of our planet is covered by ocean. Also, a meteor, the evidence of a meteor impact can be covered by desert sand or ice being redeposited over the top of it. And the loss of MH17 in somewhere in the Pacific just illustrated how fragmentary our knowledge of the world's seabed is. Hello. Today's episode, number 4, we're going to look at the Dryas periods of sudden climate change.
So, what are we going to discuss today?
Right. I think civilization is a delicate thing. At least 10 events have occurred in the last 20,000 years which would have destroyed our comfortable lives, if not thrust us back right to the Stone Age. In the previous episode, we looked at 3 types of events which would be extinction level events threatening humanity: supernova, meteors, and megavolcanoes. We also looked at the evidence for probably the most recent extinction level event, at least there was a regional extinction level event, where we have the best evidence to review. And this was the meteor impact in Greenland in 10765 BC, very close to that, which I refer to as the Hiawatha impact because it impacted onto the Hiawatha Glacier. For this event, we've identified the impact site, the type of material that impacted, we've got the date, and we've got a good idea of its effects. It incinerated the vegetation growing across North America. It vaporized or liquidized a large proportion of the Laurentian ice cap covering Canada. It plunged global average temperatures by about 6 degrees centigrade in maybe 1 or 2 decades, and it increased global average sea levels by 30 to 40 meters. So it's quite devastating. But this event was only one of a series of catastrophes that have occurred between about 17,000 BC and 9,000 BC. Climatology reveals a series of sudden changes in climate during this period. Today, we worry that humanity has already caused a 1.5 degree centigrade increase in global average temperatures, and we feel the uncomfortable climate impact. Our own activities have probably caused global annual average temperatures to reach 15 degrees centigrade for the first time since humans have been on the planet. This is the highest level since our modern species, Homo sapiens sapien, emerged around 200,000 years ago. When we first emerged, the climate was going through a cycle with a duration of about 110,000 years. Global average annual temperatures went on a cycle from a low of about 5 degrees centigrade at the low point in the sort of ice age maxima, up to about 12 degrees centigrade at the warmest period. Both extremes lasted between 5 and 10,000 years. So most of the time humanity had been on the planet, we witnessed a very slow warming from 5 to 12 degrees over a 50,000 year period, followed by a warm or a cold period, 10,000 years, and then 50,000 years of slow declining temperature. It was something that we could adapt to. Then something happened. The last ice age maxima was between about 24,000 BC and 19,000 BC, after which a slow warming began. If the previous cycle had continued, today we would be close to halfway through that steady warming. Global average temperatures may be around 8 degrees now, but it would continue warming for another 30,000 years on a slow track. However, ice core analysis shows the climate went crazy. The first detailed work to identify that something unusual had happened used the frequency of the seeds of an Arctic flower, the Dryas. It tracked the frequency that these seeds were put in the ice cores as a proxy for whether the climate was warming or cooling. And it was the rate of change which astonished researchers, because it implied very abrupt, unusual changes in global average annual temperature. Initially, these variations were divided into an older and a younger, but as more data became available, they decided to divide it into 3 periods. Now, with much more sensitive analysis of ice cores using variations in the isotopes of nitrogen and argon, much greater detail has become apparent, and I predict that those 3 periods will be divided maybe into 10 periods.
There seems to be a pattern of cooling followed by warming.
Yes, there is a pattern of sorts. The pattern is of sudden changes, sudden increases in global average temperature and sudden falls in global average temperature. Why was unknown, indeed. It's still very puzzling. The first of these events, which I think will be broken down into a more detailed series, is referred to as the oldest Dryas. Covers just over 4,000 years and contains probably 6 abrupt changes, series of fairly small ones, followed by a massive increase in global average temperature of about 12 degrees centigrade. And that happened in a few decades. So staggering change for people to live through. The oscillations referred to as the older Dryas, much shorter period. Readings that we have from Canada and from Greenland show slightly different dates, about 200 years difference, but with a duration of around, say, 400 years. So relatively short, during which we saw 2 declines and 2 increases in temperature, in the range of about 3 degrees centigrade up to 5 degrees centigrade. So those changes were relatively less, but still quite extreme when they occurred, particularly if you put it in the sort of context of what we are going through today. We are concerned that we're experiencing some climate instability, global warming, but the magnitude we're experiencing today, we're worried about an increase in global average temperature of 1.5 degrees centigrade since the beginning of the Industrial Revolution, which was 200 years ago. These guys suffered these changes in 2 or 3 decades. So massive. It would be within people's lifetime, they would experience a multiple of what we've experienced over 2 centuries. The pattern of the most recent of these periods, referred to as the Younger Dryas, which is only less than 1,200 years, started with a sharp 6-degree fall in temperature which I attribute anyway, to the Hiawatha impact. And I think there's massive evidence to support that. And it ended with a sudden 10 degrees centigrade rise, very close to the year 9620 BC.
These were huge changes. What could have caused these disruptions in the climate?
I think there's only two potential causes that have these effects. Either a meteor impact or a megavolcano eruption. Generally, cooling will come from lots of dust, an ejector being thrown up into the atmosphere. And if sufficient is ejected into the atmosphere, it can block out the sun. So you starve the planet of sunlight. And there will be other effects as well, but the temperature of the ground level will fall. Rises in temperature could occur from, again, both megavolcanoes or from meteorites. Now that may sound a little strange. Magma tends to be more acidic. So if a volcano is initially venting ejecta into the upper atmosphere, blocking out the sunlight, it will also be venting greenhouse gases and acidic material on the ground or in the sea. So a volcano may initially reduce temperatures but lead to subsequent increases in global average temperature. And historically we have some good examples of that that's happened on a massive scale. For example, the Siberian steppes, which is an area of magma covering a very large part of Siberia, which is estimated to be about 4 kilometers thick and covers thousands and thousands of square miles. That happened a long time ago, so it certainly didn't affect this period. There's also the possibility that a volcanic eruption can occur undersea. That would tend to reduce the amount of ejecta getting into the atmosphere. But of course, the gases that are vented would still bubble up. They would acidify the ocean, leading to evidence, which we would pick up quite easily, of local extinction level events where a whole range of marine species will be killed off. And we haven't detected anything like that. So I think the most likely culprit for these events causing the temperature both to rise and fall would have been meteors.
How can a meteor draw up huge amounts of ejecta upon impact, lead to a rise in temperature?
Good question. That would happen to all impacts when they occur, the initial impact. It doesn't really matter for a meteor whether it impacts on land, on ice, or in the sea. You can imagine quite a bit of the ocean, maybe 5 kilometers deep, but your average meteor is coming in at between 18 and 20 kilometers per second. So 5 kilometers of seawater, that's less than 1/4 of 1 second. It really doesn't have any effect on the impact of the meteor. So wherever it comes, it will throw lots up to the heavens, as it were. But the difference can be the composition of the material that's impacting. So if we think back to Chicxulub, the meteor that killed the dinosaurs, that was comprised, or believed to have comprised, mainly carbonaceous chondrite. Now that led to a substantial increase in global average temperatures. But the Hiawatha impact, 10765 BC, is believed to be solid iron. So as well as blocking out the sun with all its ejecta, there was no subsequent increase in temperature from that effect. But if we have had a number of meteor impacts which have given rise to increases in global average temperature, they must have had material composition which, combined with the seawater or just on its own, raised global average temperatures. It's a puzzle. We don't have the answers to it yet. It's probably worth noting here one point of detail, because I've mentioned the younger Dryas and this Hiawatha impact quite a lot, and I encourage you to do your own research look up the details, buy the book, but also have a look at what information. There's an amazing amount of information now on these things. And you may be confused by some recent announcements. It was November 2018 when a team from NASA identified this massive impact under the Hiawatha Glacier, 31 kilometers wide. They were truly excited. This is a really big impact crater. 3 months later, in February 2019, they found another one next door, 100 kilometers away, very much in the same area. That one is even bigger, 35 kilometers wide. I think it's currently ranked as 22nd biggest impact crater that's been found on Earth. Now, the characteristics of the two craters are different. The first one, which is the one I'm referring to here, ice cores and radar probes show that the image of the crater looks fresh. You can see the roughly circular rim, the central the depression of the crater very clearly. And the layers of ice are smooth down to about 12,000 years ago. Or when I say down to 12,000 years, if you imagine the glacier is slow moving, each year you get fresh snow on the top. So as you dig down, you're going back in time, in effect. Older ice has been moving across, and then fresh stuff's on the top. So by analysing that core, you can work out how long the ice has been there. But below about 12,000 years ago, suddenly you find huge boulders the size of trucks, basically catastrophically disturbed landscape within the remains of the crater. For the other impact crater, which is slightly bigger, the smooth ice goes right down to the bedrock, and it's aged to over 80,000 years. So whenever that erupted, it was clearly not in this period at all. The initial estimates, based on the very eroded shape of the crater and its rim, is that it could be as much as 100 million years old. So totally different. Interestingly, two different university research teams, one from Denmark and one from Sweden, have been looking at it recently, and independently they've both come up with a dating of 58 million years ago. Now 58 million years ago puts it a mere 8 million years after the dinosaurs were wiped out. But 35 kilometers wide, the world would have known about it. Putting that into comparison, Chicxulub that killed the dinosaurs, that was 200 kilometers wide. But 35 still make quite a splash.
So, what's your conclusion then?
I think it's most likely that the culprit for all of these sudden changes in climate were meteorite impacts. There can be little doubt that North America was devastated by a meteor impact around 10,765 BC, because we have evidence from samples of the black matte material, which is about 1 centimetre of pure carbon, lying at that level of age right across the continental US. That black matte contains, every sample has been taken, contains nanodiamonds, helium-3, carbon fullerene. Those are only made from a meteor impact, or helium-3 from off-planet. So they have only come from a meteor impact. And the radioisotopes in that mix give us an accurate dating mechanism. Why do I think it's meteors? Because we don't have sufficient evidence, or any evidence really, of major volcanic activity during this period. The only major volcanic activity during the time humanity has been on the planet is Toba, but that's 74,000 years ago. The biggest volcanic eruption in North America in the last 20,000 years was Mount Mazuma, which is about 5,700 BC. But on this scale, it was tiny. The ejecta has been estimated at 160 cubic kilometers. I know that sounds a lot, but Tuba was 13,000 cubic kilometers, so 100 times bigger almost. Whilst, for comparison, Mount Vesuvius is about 3 cubic kilometers. So people close to Mount Mazuma remembered it, and we'll come on to that actually. But it certainly didn't create a continental extinction level event.
So you think the meteors were the cause?
Yes, that's my conclusion. The trouble is we haven't found the evidence. So it's really by the elimination of the alternatives.
Mm-hmm.
Also, there is an issue around the fact that 75% of our planet is covered by ocean. Also, a meteor, the evidence of a meteor impact can be covered by desert sand or ice being redeposited over the top of it. And the loss of MH17 in somewhere in the Pacific just illustrated how fragmentary our knowledge of the world's seabed is. So we may find other impact sites or even huge underwater volcanic activity that could have given rise to these sorts of changes. I think now interest has been spiked. More research funds will be going into trying to understand what caused these events. Certainly more work should go into planetary identification and protection of inbound meteors. In the next episode, we will discuss what our ancestors encountered and how they reacted. Thank you.